Assalamualaikum and hello everyone. We are from Group E10 and this is our video for our math project, and today we are going to talk about the population of Luxembourg. Alright, and for our first objective, we are going to apply the first order of differential equations, specifically the multivariate model in modeling the population growth of Luxembourg from 2003 to 2023. And the next one, we are going to predict the future of population in Luxembourg after 2023 using the multivariate model. Also, the third one, we are going to predict the past number of population in Luxembourg before 2003 using the multivariate model. And the fourth one, we are going to calculate and analyze the percentage error between the predicted and the actual population values. And last but not least, we are going to identify the reasons why the expected total of population in Luxembourg from 2003 to 2033 isn't exact as recorded data. Alright, before we get started, for those who don't know, Luxembourg is a small, wealthy EU country that has seen steady population growth due to economic strength, immigration and high living standards. This is the table 1 that shows the actual population of Luxembourg from 2003 until 2023. In 2003, the population was about 451,630 and it steadily increased each year, reaching 663,430 by 2023. This consistent growth reflects Luxembourg's strong economy, high quality of life and immigration trends.
So to obtain the equation for the particular solution, we should use the Malthusian model from dP over dt directly proportional to population. So to turn this into the equation, we should put constant beside population, and we should integrate both sides to separate the variable. So to obtain the initial condition, we should use t equals to 0 to find the a value. After obtaining the value of a, which is equals to 451,630, we should find the constant k for the formula. So substitute t equals to 1, which is the 2004 population, 458,095, and substitute the value of t equals to 1 and ln for both sides, and we should obtain the constant value is 0.0142. So for the final particular solution, just substitute back the value of a and constant in the formula.
This is a table 2 for the particular population of Luxembourg that we use by using the Malthusian model. In table 2, in 2003, the population is 451,630, which is same with the actual population, and reaching by 2023, it is 599,960, which is a little bit off from the actual population.
Thank you, Najib. Moving on to the next task. Now, from the data that we have taken from original sources population of Luxembourg, we have created figure 1. Figure 1 displays the actual population growth of Luxembourg from year 2003 until 2033. So this graph shows a consistent trend indicating steady growth over 2 decades. The population increased from our initial year 2003, 451,630, and latest year 2023 that has the value 666,433. This increases number of population reflecting the country's strong economy, immigration, and the quality of life. Moving on to the next graph, which is figure 2, the particular solution graph. From the figure 2, illustrate a potential exponential model of Luxembourg population using the formula that we have created before. This graph estimates the future population trend based on on to the next task, which is calculation. So what we're going to do now is we're going to test the accuracy of our exponential model by implementing the Malthusian model equation, which is PT that we have created before. Now we are going to predict both past and future value. For past year 2021, we set the T as -2 and we insert into the formula. We get the population is 458,984, while the actual record population that we get from the web is slightly higher at 439,000. This shows the model provide a fairly accurate estimate for historical data. For the future number population is 2034. We set T as 21, and the model predicted a population is 618,514. But the project actual number of Luxembourg in 2034 from the web is 607,050. The difference highlights that while the model is a general trend, there might be some factors. So, why is there a difference between the actual population numbers and those predicted by the particular solution? Could it causing by some factors?
Next, for the discussion part, there are few questions that are frequently asked. Here are the questions. So for the number 1, logically it is a no because we do not know the specific reason for some of the error from each person. Next, for the percentage error, this is how we calculate the percentage error. Furthermore, for the number 3, because like I said just now, we do not know the detailed reason from each error. However, it might cause some from the external factors affected the actual data. Next, for the number 4, advances in medicine and healthcare helps reduce death rates, and as well as wars, pandemics, and natural disaster might also decrease the populations. Lastly, for number 5, some of the factors are climate change and environmental degradation that might affect our population.
Hello, I'm Isma, and today I will be discussing the task 2 for our group maths assignment. For task 2, we were tasked to find the estimated root using the Newton-Raphson iteration method. The Newton-Raphson iteration method can be found using the given formula, which is nx plus 1 equals the x n minus the function over the derived function. By the way we implemented our formula is by first picking a root from the given question. The question gave us the given root of 0 to 2.5. We could pick a value such as a 1, which we did use for our calculation. Firstly, we plugged in the values such as 1 into our formula to get the second value of x. So far, for the second value of x, we got the value 1.068 for our root. Next, we repeated the formula by plugging in the values to get these tabulated data points, which led us to getting the final root values, which is 1.06353. Next here is the combination of both graph of our graph of functions. Afterwards, we needed to calculate the percentage error for our iteration values. Percentage error could be found using the formula xn minus xm minus 1 over the original value of xn times 100%. For the first iteration, we managed to get the value of 6.367%. However, according to the following data points, we managed to get 0% in the 7th iteration. That's all for the percentage error part, of course. We can conclude task 2, the discussion of task 2, by concluding that the higher the number of iterations, the precision of the root value compared to previous iterations will also increase. As for recommendations, for task 2, it is recommended to use more than one initial first root guesses, as we only use the root 1 for our approximation. This will allow us to recheck and cross-reference our obtained root to ensure a correct answer. If done correctly, the final approximated root should be equal to the other final roots. That's all for us in group 2. Group 4. Yeah.
With all things comprehend, task 1 goal have been completely met. We comprehend completely the application of first order differential equation from MAT099 course to our project. Using this strategy, we were able to determine the increase in population of Luxembourg from 2003 to 2023 in task 1. We computed percentage error and the difference between the estimated value based on Malthusian model and actual value using the estimated number. So based on the value, we determine the causes of the values unfavorable comparison. In addition, we need to identify the real factor that caused increase in population. One of the many benefits of task 1 was that it allowed us to apply mathematical techniques such as Malthusian model, which is derived from first order differential equation to solve problem in a realistic manner. For task 1 recommendation, from what we observed, we recommend that we should use the monthly data instead of yearly as the time difference is big. Other than that, we also recommend that the study of population growth in Luxembourg need to be continued in the future. This can allow the researcher to estimate the number of population in Luxembourg in the upcoming year and to make sure the population grows just like how the particular solution graph has shown.